Hello dear students, this is your Jagan sir.
Welcome back to our physics channel. Welcome back to our YouTube channel, Physics with Jagan sir. And today we are going to discuss fourth class on work energy theorem. And first point in this in this class, we are going to see what is work energy theorem. See here, suppose an object is present, and we know that work done is equals to force into displacement. Work done is equals to force into displacement. First topic, first concept. And here force value I can write as ma, and a is equals to m dv by dt into dx, m dv into v, since v is equals to dx by dt. So mv dv from initial velocity u to final velocity v, right? Then work done by all the forces, work done total is equals to half m v square u v, right? V dv is equals to v square by 2. I am taking 2 outside. Then work done total is equals to half m v square minus half m u square. Then work done total is equals to kinetic energy final minus kinetic energy initial. That is, work done by set of all the forces is equals to change in kinetic energy. Work done by set of all the forces is equals to change in kinetic energy. This is what is work energy theorem. This is what is work energy theorem. First point. Then second point is, based on these concepts, let us go through with some numericals, 2-3 numericals. The only force acting on a 2 kg body, m is equals to 2 kg. 2 kg body, as it moves along a x-axis varies as shown in the figure. The velocity of the body at x is equals to 0 is, that is, initial velocity value is 4 meter per second, 4 meter per second, and graph is given. What is the kinetic energy of the body at x is equals to 3? Now see here, question A, at x equals to 3, at x equals to 3 means total work done, and here work done is equals to f dx means work done is equals to area under fx graph, area under fx graph, right? Now up to 3 seconds, up to 3 seconds, up to 3 seconds, area is equals to, from upward triangle and downward triangle, from 0, 4, 1, half into base into height, and it is positive, it is negative. In the first class itself, last class itself, I had told you positive work done, negative work done, and here in the downwards to the origin we consider as negative. So minus half, base value is 1 and height is 4, then up to 3, base into height, that is 1 into 4, minus 1 into 4, then these two will get cancelled, then area is equals to minus 4, minus 4, right? Then area means work done is equals to magnitude 4 joules, and that work done is equals to change in kinetic energy, change in kinetic energy. Now minus 4 is equals to half, and kinetic energy of the body, they are asking kinetic energy of the body. So kinetic energy minus initial kinetic energy final, minus half m u square minus 4, and see here initial velocity is given as 4 meter per second. So kinetic energy final, half, mass is 2 kg, 4 square, then kinetic energy final is equals to 16 minus 4, right? Then kinetic energy final is equals to 12 meter per second. This is what is for A bit. Now let us go for the B bit. At what value of x will a body have a kinetic energy of 8 joules? Right? Then work done is equals to area under fx graph. Right? Work done is equals to half into base into height minus half into base into height minus, see here, up to here we had successfully completed, but they are asking at what value of we are get kinetic energy, as 8 joules. From 2 to rightward direction it is going, so x minus 2, already 2 has been completed, up to 2 diagram has been, representation has been completed. Then x minus 2, right, x minus 2 into 4, right? X minus 2 means up from here to so far, rightward direction, and 4 is the height, width. Next these two will get cancelled. Work done is equals to minus x minus 2 4, one second, it is loading actually. Right, minus 2 into 4, and let it be equation number 1, and work done is equals to change in kinetic energy. Final kinetic energy they represented as 8. Initial kinetic energy we found from the A bit as 16. So work done is equals to minus x minus 2 4 minus of x minus 2 of 4 minus 8 minus get cancelled 2, x is equals to 4 joules. This is, sorry, x is equals to 4 meters. Right, in terms of meter, x is equals to 4 meters, we will get the kinetic energy as 8 joules. Right, then C bit, what is the maximum kinetic energy attained by the body between x is equals to 0 and x is equals to 5 meters? See here, the object having positive work done up to 1 meter only. After that, it is getting negative work done. So maximum kinetic energy we will get at x is equals to 1 meter. At x is equals to 1 meter. And what is that maximum kinetic energy they are asking? So work done is equals to change in kinetic energy, area under graph up to 1 meter, half into base into height is equals to kf minus ki is equals to 16, which we had already found from the A bit. Then this is equals to 2. So kf is equals to 16 plus 2. So kf value is 18 joules. This is the answer for CB. And again, I am saying up to 1 meter only work done is positive. So whenever work done is positive, there only we will get the maximum kinetic energy. And after that, we have negative work done. So negative work done means we will get negative or less kinetic energy. This is what is for first question. Let us go with the second question. And again I am saying one and only one most important point is here we are discussing most critical problems, as I have discussed in the last one, which is little bit critical problem, and my intention is to make you to be more comfortable with the subject. That's why I am discussing critical problems, and if you are really familiar and really comfortable with this type of critical problems, you can able to solve normal problems very easily, and you can crack your entrance examination very easily. Trust me, and try to practice the class notes thoroughly. It will definitely helps you a lot. Then next one is, it is also a little bit logical problem. A bullet leaving a muzzle of a rifle barrel with a velocity of v penetrates a plank and loses 1/5 of its velocity. So velocity is lost to 1/5 means remaining velocity is 4v by 5. It then strikes the second plank, which is just penetrates through. Find the ratio of the thickness of the planks. Supposing the average resistance to the penetration is same in both the cases. Right. By using work energy theorem, work energy theorem. See here, work done is equals to change in kinetic energy. Work done is equals to force into displacement. The thickness means, let us assume it as resistance, force, resistance, force I am representing with the R, and T1 is the thickness, and half m Vf, that is 4V by 5 whole square minus half m V square. This is final kinetic energy, this is initial kinetic energy, right? Which is equals to 16 minus 25 half mv square minus half mv square 16 by 25 minus 1 half mv square rt1, then rt1 is equals to minus 9 by 25 half mv square. Let it be equation number 1. Similarly, passing through second plank, rt2 is equals to half, it is coming to rest in the second plank, but when it is entering into the second plank, its velocity is 4v by 5 whole square, right? Then rt2 is equals to minus half mv square 16 by 25, 16 by 25, then divide 1 and 2, 1 by 2, again it is loading. Right, let it be equation number 2 by dividing 1 and 2, rt1 is equal, rt1 by rt2 is equals to minus 9 by 25 minus 16 by 25, then t1 by t2 is equals to 9 by 16. This is the answer for second question, right? This is a little bit logical problem, hope you are understanding very clearly. And third question is, third question, a block of mass M is moving with the initial kinetic energy V naught towards a stationary spring of stiffness K attached to the wall as shown in the figure. As shown in the figure. See, it is in normal position. Spring is in normal position. It is moving with a velocity V naught, and when it compresses a distance x, and it is coming to rest at that position, then work done by spring is equals to minus half kx square. And why I am writing minus half kx square, which I discussed in our last class very clearly, right? And if you have any doubt, you can please go back to our class, last class. There you will get there you will find the answer for minus kx square. Then by using work energy theorem, change in kinetic energy, set of all the forces acting on the object is only one spring force. So work done by spring force only we need to consider, which is equals to half kx square, change in kinetic energy. So finally object is coming to rest, and initially it is moving with a velocity of v naught. Then minus get cancel, obviously it is 0, half get cancel, and they are asking find the maximum compression in the spring. So maximum compression is equals to x is equals to m by k v naught square under root of this is what is the maximum compression in the spring. right? Then is the work done by the spring is negative or positive? Yes, just now I told you work done by the spring is negative because it is compressing. And why we are getting negative answer when it is in compressing state, that we had already successfully discussed in our last class, right? Then see here, a particle slides along a track with elevated ends and and a flat central part as shown in the figure. The flat part has a length L is equals to 3 meters. The curved portions of the track are frictionless. For the flat part, the coefficient of kinetic friction is mu k is equals to 3.0.2 and length of the track is 3 meters. Length of this portion is 3 meters. The particle is released at a point A which is at a height h is equal to 1.5 meters above the flat part of the track. Where does the particle finally comes to rest? So initially the object is starting from the rest and finally the object is coming to rest, right? Then when the object is moving on this rough surface, then frictional force will act in the leftward direction, and that force is equals to mu n mg. So F is equals to mu mg, and suppose it is displacing a distance x, then work done by frictional force is equals to mu mg x cos 180 degrees. Because object is moving in this direction, friction is acting in the leftward direction, so angle between the displacement and friction is 180 degrees. So the answer for the work done by friction is equals to minus mu mgx. This is first part, and apart of this, the bowl is like this. So when the object is starting its journey from here, and work done by gravity mg, work done by gravity is mg, and the displacement of the object is this one is the height. So work done by gravity is equals to mg. H is also in the downward direction, and cos 0 degrees is the angle between displacement vector and mg, and work done by gravity is equals to mgh. Now work done by all forces is equals to change in kinetic energy. This is what is work energy theorem. Right? Set of all the forces acting is work done by gravity, work done by friction, change in kinetic energy. Object finally comes to rest. Initially the object is also at a rest position, right? Then work done by object is mgh minus mu mgx is equals to 0. So mgh is equals to mu mgx, mg get cancelled, x is equals to h by mu. Height value they represented as 1.5, that is 3 by 2, and coefficient of friction is 0.2, so 2 by 10, so which is equals to 30 by 4, which is equals to 7.5 meters. 7.5 meters means obviously the object starts its journey, and of course they represented this with 3 meters. Length is 3 meters. 3 meters. So object comes to up to here, moving in the upward direction with certain amount of velocity. Again it is coming back. So the velocity what it is moving at this point remains the same when it is coming down. So again object comes to rest. Same procedure will takes place here also, upwards and downwards, and finally comes to middle part and comes to rest at the middle of the plank. This is what is most important problem, logical and critical problem. I hope you understood very clearly. And before you are going to practice your worksheets, better to follow my class notes. And once you are comfortable with my class notes, then you can try to practice your worksheets. And if you need any worksheets, let me know through the comment box. Meanwhile, I am daily posting our daily worksheets in our Telegram channel, and also weekly examination papers also in our Telegram channel, Physics with Jagan sir. And all the best. Have a great day. Take care. Bye bye.